Students, welcome to part 2 of capsules. In this video, we are going to study about raw materials that are used in manufacturing of capsule. So, basically, the various raw materials which are used for capsule are gelatin, which may be either type A or type B, plasticizers, so glycerin USP or glycerol 85% and 98%. Its function is to impart softness, elasticity and hardness. Then the next constituent is preservative like that of methyl paraben or sorbic acid 0.2%, and its function is retard growth of microorganisms. Then solvent is used. Solvent, for example oils, in order to enhance elegance. Then opacifying agent like that of titanium dioxide in 0.2 to 1.2% concentration, and its function is to minimize transparency. Then colors like that of vegetable colors or FD&C approved colors, D&C water soluble dyes, right? Certified lakes can be used, and their function is to impart pleasant appearance to the shell. Flavors can be also included like that of ethyl vanillin in 0.1 to 2% concentration in order to give a good flavor. Sugar can be used, example sucrose up to 5% in order to give a sweet taste. Thickening agent like methyl cellulose can be used in order to adjust viscosity of gelatin, and water can be used depending upon the need. So these are the various materials that are used as raw material for preparing of capsule shell. Now we'll be seeing these components one by one. The first one, that is gelatin. So gelatin is by far most commonly and most well-known material used to produce hard capsule shells. It is a generic name or it's a generic term for mixture of purified protein of fractions obtained by irreversible hydrolytic extraction of collagen obtained from the skin, white connective tissue, and bones of animal. Depending on the source of collagen and the method of extraction, two types of gelatin can be produced, that is type A gelatin and type B gelatin. So type A gelatin is made from pork skin via acid hydrolysis and has an isoelectric point between 7 and 9, whereas type B gelatin is prepared by alkaline hydrolysis of bovine bones and has an isoelectric point between 4.8 and 5. Because of this difference in isoelectric point, both gelatin, that is type A and type B, they show solubility difference at different pH value. Also, gelatin is stable in air when dry but is subject to microbial decomposition when it becomes moist. Traditionally, capsules were manufactured by using both types of gelatin, but combination of pork skin and bone gelatin are often used to optimize shell characteristics because bone gelatin contribute firmness, whereas pork skin gelatin they contribute plasticity and clarity. Okay, then coming to ideal properties of gelatin. So it should be non-toxic, it should be readily soluble in biological fluids of at body temperature in and is digested by proteolytic enzymes. Then it produces a strong flexible film. It has gelling power, forming thermo reversible gel. Okay, then here is preparation of gelatin. You can see preparation of gelatin can be done by using dry bone, calf skin or pork skin. Okay, so dry bone, it is washed using 5% HCl 0 and sorry, it is stored in 5% HCl for 10 to 15 days. Then lime 10% is added for and it is stored for 4 to 8 weeks. Washing and pH adjustment is done. Okay, then the process is extraction, filtration, cooling, sterilization and drying. Then for calf skin, initially calf skin is washed, then lime 10% is added and stored for 6 to 12 weeks. Then it is water washed, okay, 10 to 30 hours, and then The remaining process are same, that is extraction, filtration, cooling, sterilization and drying. And for pore skin, so pore skin is washed, then 1 to 5% HCl is added and it's stored for 10 to 30 hours. Then acid removal is done, and then the same process of extraction, filtration, cooling, sterilization and drying is carried out. So this is how gelatin is prepared. Then coming to next material, that is HPMC. So hydroxypropylene methyl cellulose is globally known as hyperomellose and manufactured by chemically made polymer cellulose. It is considered safe for normal human consumption and is commonly used as an option instead of gelatin because of its vegetarian source and its physical appearance to gelatin. Then, this plant derived cellulose has been an option for vegetarian capsule in pharmaceutical application since 1998. Then, it is physically stable polymer that's resistant to stringent heat and humidity condition with a low moisture content that make it suitable for moisture sensitive ingredients. Also, HPMC is used in film coating or a sustained release tablet material in pharmaceutical field. Then HPMC based capsules can also play a role in addressing poor bioavailability. So here are features of HPMC capsule. They are derived from natural plant source cellulose which perform at par with other kind of capsules. Then chemically stable and inert, compatible with wide range of formulations. Also, HPMC capsules meet functional, cultural and dietary preferences and compliances. Then they are a preferred choice for moisture sensitive and hygroscopic formulations. And HPMC capsules are machine friendly, design ensure smooth encapsulation on semi-automatic and automatic filling machines. Then here there is difference between HPMC vegetarian capsule and gelatin capsule. So this is called as vegetarian capsule as no animal part is being used in HPMC. So the first difference characteristics is stability. So higher stability due to low moisture content, as moisture content in HPMC capsule is 3% to 7%, whereas for gelatin capsule lower stability due to higher moisture content, right? So for gelatin capsule it may be 13% to 15% and more sensitive to extremes of humidity. Then cross linking problem is absent with HPMC, whereas cross linking leads to reduced solubility which can be induced by high humidity, temperature, UV light and specific fill component. Then tolerance towards fill composition, so suitable for variety of fill material including those containing aldehyde group, whereas for gelatin capsule they are suitable for dry and powder material, may not compatible with some liquid materials such as oils and gels with aldehyde group. Then further difference, so degradation by light, so HPMC do not get degraded, whereas gelatin capsules can possibly get degraded. Then degradation by heat, approximately above 80 degrees Celsius for HPMC, whereas for gelatin capsule it is approximately above 60 degrees Celsius. Then oxygen permeability is high of HPMC vegetarian capsule, whereas low for gelatin capsule. Then next point for differentiation is dissolution in water at room temperature. So HPMC is soluble, whereas gelatin is insoluble in water at room temperature. Then coming to next component, that is plasticizers. So plasticizers are added to gelatin to reduce the rigidity of the polymer and make it more pliable. Common example of plasticizers are glycerin and polyhydraulic alcohol. Polyhydric alcohol. Water is also a good plasticizer and is naturally present in gelatin. Then coming to next component, that is preservatives. So preservatives, often paraben esters, are formerly added to hard capsules as an in-process aid in order to prevent microbial contamination during manufacturing. However, manufacture operation or manufacturers operating their plant to GMP guidelines no longer use them, as it is assured that in the finished capsule the moisture level, that is 12 to 16% weight by volume, are such that the water available or water activity will not support bacterial growth, because the moisture is too strongly bonded to gelatin molecules. That is, here the water is not free itself. Okay, the moisture is not available, it is all bonded with the gelatin. Therefore, there is no need of adding preservative. Then coming to next one, that is opacifying agents. So opacifiers like that of titanium dioxide may be included to make a clear gelatin opaque. Then opaque capsules may also be employed in order to provide protection against light or to conceal the content that have been stored therein. Then coming to next one, that are colorants. So colorants used must meet the regulatory requirement for those countries where the product will be sold. Example of commonly used capsule colorants include synthetic dyes such as azo dye and xanthine dyes. Also, iron oxide pigments are used. Then coming to next one, that is water. So hard gelatin capsule contains around 12 to 16% water, but the water content can depend upon storage condition. Then coming to next one, that is gelatin agent. So gelatin agents is used because iron is always present in raw gelatin and should not contain iron more than 15 parts per million. Therefore, gelatin agent may be used for preventing the reaction of iron with materials or colorants. Okay, so these are all the different materials that are used in manufacturing of empty gelatin, or sorry, empty capsule shells. So thank you for watching till end.